Okay, greetings. Now we are going to be analyzing and prepare making a graph so that we're able. So let me just say that we're going to be preparing a graph so that we can analyze data. All right. But even before you can analyze the data, you must know how to plot a graph. Now, in the case that we're supposed to plot a graph, let's see if we can get a text box here. In the case that we need to plot a graph, the instructions would have been um, quantity A, let's say quantity A, let's say A versus B, right? A versus B. Now, what this means?
The very first thing I need to understand when it comes to physics, chemistry, maths,
And to some extent biology. The quantity that is here, A, would most time go on the y-axis, and the quantity here, B, most time goes on the x-axis. Okay, now that's the first thing that we want to do. Now let's see if we can duplicate this. Duplicate again. So I am going to take A, important, I'm going to take A, I'll take this letter here. Let's see what's going on here. Refresh. Alright. Get anything from it. Go again. Go again. Let's go move. Take a move. Alright. So we're back in business. So we're talking about A. And let's for this. Let's get rid of the B. Let's get rid of all of those and call it B. So looking, go back to close, moving again, drag, come down here. So we look at our quantity A versus quantity B. That's the first thing that we want to get. All right. Now the mere fact that that instruction gave you that, you could go working from points, right? I'll show you the breakdown in a few. We're working for points. So the first thing you know that you must have a title. So a graph showing the relationship between A versus B. Alright, and that would be our title right there, our most suitable title, and you put it up there. So to talk about the class system, there's a class acronym that is used most frequently among uh, markers, examiners, all right, and for that reason, we use the class system as a means of getting the work done easily and accurately, and to some extent standardized when marking graph. All right. Uh, let's switch over to the Jamboard. Let me write it quick and fast. So we're talking about class E for plot, L for the line that is drawn, A for leaving your axis is correct, S choosing a suitable scale, and T your title of the graph. So far we have done, um, we have just made our title and our axis. 2, 4, 6, 8, 10, 10 marks, right? So working for 10 marks, um, on average, 2 for each. So we have the axes labeled and we have the title. One more thing that I must point out, it is important that you put slash on whatever unit that quantity A is measured in. So I just put that to remind you that the quantity is supposed to go there and the unit slash unit. All right. So whatever unit E is measured in, we must respect that those um, and put them in. So we have our title 2 marks, 1 mark, 2 mark for axes. Now let's attack, go over, show you what we're talking about for the delay. I put in A slash unit, B slash the unit. All right, whatever unit that E is measured in, you put a slash, then you put that unit. So if B was time, then slash seconds. If A was length, it would be length slash meters. Good. And we have our title. So 2 marks for the title, one mark for the y-axis, another mark for the x-axis. So we're at 4 marks so far. All right. So on a typical graph paper, you have basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Some people have 12 going up, some people have 11, some people have 9 going across, some people have 10. 1, 2, 3, 4, 18, I should say. 1 going across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right, let's go again. I should make my correction quick and fast. What I need to correct is that going up most time we have 22 lines going up. All right, or 23 for some person, between 21, 22, 23. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we are going to say that this graph, instead of being portrait, meaning it is standing up, this would represent a graph that is turned to the side. We call that landscape. It's like taking your book and then just turn it to the side. All right. So let's use a line to show you what I mean. So I could have this being the portrait, but let's get rid of that. So that, get rid of that. But this would, if you turn it this way, then we call it landscape. All right. So get that out of the way. And I love to do my graph like this. For some reason, it allows me to get 70% most time. All right. But because of the space on the screen and I want the five squares and the 10 squares to show, I'm using this window. So um, before leaving any bad comment or thumbs down, let me just highlight that's the reason why I am going forward with this um, video. Now, if we should have some values, all right, let's see if we can find some suitable values and get them plotted. Now, if we should have some values that needs to be plotted, there are some things that we need to first make note of and ensure that we understand these values. All right. Now, I'm going to take, for example, going to take a sample from a CXC paper. It's not the correct thing, but just to show what we're working with. All right. So we have 10, 20, 30, 40, 50, 60. And then we have 6, 10, 18, 24, 30, and 36. All right. Now, let's see if I can get. Now, these values are going to represent the X value. All right. Let's see if I can get by the line. All right. While these values will represent my Y value. All right. So this will be represent my X values and these will represent my Y values. Okay. All right. So we want to ensure that we note a few things here. We need to find out on the x-axis what is the largest value on the x-axis, and we see it is 60. Right? Now, if we go over to our graph, we have these lines to work with. So we see on a typical graph, 5 spaces would represent 1 centimeter. So let's go over back to Jamboard and put that down. All right. I want to know that one on a typical paper, 1 centimeter equal 5 spaces. All right. And again, this is 2 centimeters, basically matches up to 10 spaces. Good. All right. So let's go over back to the graph and analyze the graph. We have 1, 2, 3, 4, 5 spaces, right? 1, 2, 3, 1, 2, 3, 4, 5. Yes. So if we should go up by 1 centimeter, so if we should say, let's get something to mark the points. All right, let's use this. All right, so we use this to mark our points. So we say, well, point 1 centimeter. So 10, 20, 30, 40, 50, 60. And the mere fact that that is 60 right there. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, going up. This graph would be too small. All right. So suppose we use 2 centimeters. to represent where we're coming from and what we're plotting. All right. So let's go with 2 centimeters. So 2 centimeters would match up to 10 spaces. So we say 1, 2, 3, 4, 5, 10, 20, 30, 40, 50, 60. All right. We see we're going a bit more wider than before. We have like 10, 20, 30, 40, 50, 60. Right? We use 1, 2, 4, 5, 8, 10 as suitable space numbers of spaces or for scaling down. We use those numbers. We avoid numbers such as 3, 6, 7, 9. Those numbers are very problematic. Some instances you can have 5 being problematic, but depending on how you're scaling, if you're going up by 10 or 100, um, that's a very suitable number to go with. But 5 is basically, on average, a safe number. All right. So if we have 2, 4, 6, 8, 10, 12, we have 20 lines, and then we have used 12 out of the 20 lines. We are more than halfway the graph, right? So it is. So we could also make a quick check if every 4 spaces 1, 2, 3, 4, 10, 20, 30, 40, 50, 60 will be too every 4 spaces for 60 will be too much. All right. So what we can do now to mark off those points, we could use a line, use a line, use a line. All right. Could use a line. So each of these we see we have 10. So I am using numbers to be general, all right, to make a general statement to show you the principles. So on here now, on here for the x-axis, we know that we use 2 centimeters, and those give us a units, and because what that is saying, whatever number you had put there, you had gotten. And in this case, we're going up to 10. We go over A units. So the general is that's the general form. But for this case, we went 2 centimeters, and that equal to 10 units. Good. So that was so cancel. That was for analyzing our x-axis. I was analyzing our x-axis. Good. So on our x-axis, that's what we had. Now let's see what is on our y-axis. Our y-axis, we have the highest number being 36. All right. So we're going over back with the graph and see what we have to work with. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we divide that, we are looking at, if we put 36 on the 10, would be going up by 40. 40 is a good number. Let's round off 36 because 30 is a bad number, but the highest value is 36. So we could round off 36 to 40. And if we do that, we can say 10, 20 every 2 centimeters going up. And then let's see what goes on. So let's get a point here. So we say 10, 20, 30, 40. 1, 2, 3, 4, 5, 2, 3, 4, 10, 10, 20. Still would be it off going up there. Alright. 2, 4, 6, 8, 10, 12, 18. Still only reach going up. Alright. But this should be a very nice graph. We have views 1, 2, 3, 4, 5, 6, 7, 8 lines out of a maximum of 12 or 11 lines. So we're still in the safe. Alright. But remember, this is 36, so we were going up by 5, 5, 10, 15, 20, 25. No, 10, 20, 30, 40. That's what we use it. 10, 20, 30, 40. Let's go 5, 10, 15, 20, 25, 30. We want to reach it. So we're going up by 10 also on this graph, on this axis. Let's cancel that. Do that out. Go back for this tool. So we say on the y-axis, alright, so let me just take out this general statement. So on the y-axis, we measure it also by 2 centimeters. This is not always the case. Remember, we analyze it and see it is better to go up 2 centimeters um, instead of 2 centimeters instead of 1 centimeter. Remember that one space, 5 spaces is 1 centimeter. Not because you see 2 centimeter equal 10 units there because of the 10 spaces. No, right? These are the units. These are the numbers that I'm going up by. So when the examiner look 2 centimeters every other line, you should see me going up by 10. Okay, so we're talking about 10 units. All right. So that's the analysis for so that is the scale. So we have 2 marks right here. So we can go over and check right here and tick this off. Our scale has been sorted out.
Alright, we'll come back to our graph and let's put in some name. It is
Mhm. So we are going to have 10 right there. Then this is 10, and then we have do that to 20. So we create this. It's 30. So I put them on the what it is 10, 20, 30, and we have 40. that, put him down there. Carry that to 30. Alright, so let's do this first time. Let's duplicate this. So right here we have 10, 20 also, 30, 40. Let's duplicate this. This is gonna be 50. That is gonna be 60. Alright. Now it is key for me to tell you, it is important for me to tell you that we don't stop when we're drawing our graph, we don't stop at the number that we're going to be using, our highest values. On the y-axis, it is okay because our highest value was 36. So we could use 40. 40 was okay because your highest value should not be the last number on your graph. So we have 60 here, so the 60 cannot work. So we have to go to 70 on this graph. Alright, so let's put another line. Let's put another line for now, another point on the line. Alright, and let's extend that line segment. Alright. Alright, so should be able for everybody to see. Duplicate, and this is 70. Alright, so our scale is alright so far. Alright, now that we have sorted out how much these big spaces are, it is important now for us to do one important thing. It's important to find out how much is one of these lines. Alright, and you from this scale is what you see. 2 centimeters equal 10 spaces, which means that this 10 here is going to be divided by 10 spaces. Alright, and if you divide these by 10 spaces, you're going to see that each of these lines represent 1, which is the principle that you're supposed to use. This is just that it works out to be this. Right, and I'm seeing where I made a mistake here. That's supposed to be there. And put that. Okay, that's correct. No, no. So what you look from your scale, 2 centimeters equal 10 spaces. Good. And your unit, whatever the magnitude of the unit right here is, that's the amount of space that you divide this unit by. So this 10 spaces, because it's 2 centimeters. 2 centimeters is 10 spaces. We divide the 10 units by 10 spaces and we get 1. That's how we will find out we would find out the value of 1. So even at one line, even if it was, say, let's say it was 4 units, right? What that would have meant is that 10, 4 would be divided by 10. If it was 1 centimeter, this 4 would be divided by 5 spaces because 5 spaces equal 1 centimeter. Hope I've not lost anyone. I hope we are still on board. Now it's time to plot. And when we go over, I love to advise students to use these um, values first. All right. Is it possible I could get this over on this page? Is it possible? All right. Yes, I could. Let's share this instead. Share this instead. So here we go now. So 60. The trick is 60 is on the x-axis. But what we would have done now is put 36 on 36 on the y-axis. The principle in doing that is going up, right? 10, 20, 30, and 6 spaces, right? That's the principle that you would have used. You know how much, you know that these lines are 10 spaces. How would we get the 10 spaces? Look at this trick now. If I have, when I do the maths, when I do the maths, I would have had 10 divided by 10, and that gives me 1. But what this means is that each of these values here would have been divided by 1. All right. For the principle, I have 10 spaces. I have 10 spaces going up on the y-axis. All right. My first unit that I see is 10. So I divide that 10 units, all right, by the 10 spaces. I get 1. All these values in this um, column would have been divided by 1. And when I divide that by 1, I start getting my values. So 6. So my first point would be at 6. 6. So 1, 2, so 5. This is 5. This is 6. All I need to do now is go over to 10. And there I get my first value, 10. Good? So O, x value is 10, its y value is 6. Now I go up to 12. I identify 12. This is 10. This is 12. I can, since these lines are so small, I can use the 10 line, go over to 20, and then go 11, 12. Good? Now for the next point, I have 18. And what I can do, I go 18. 18 is still crowded, but I can use a 20 and go over to 30 and then come down 1, 2. 2 from 20 is 18, so I can put my point there. Good. Drop this point. Now I go up to 24. So I use 20. I identify 20 and I'm going out to 40 and I count 40. So 20 is matched with 40, but I'm not looking for 20 at 40. I'm looking for 24. So I go 1, so it is 20, 21, 22, 23, 24. So my next point will be at 40. It will be 21, 22, 23, 24. It will be right here. Good. Now at 50, I go up at 30. 30 matches up with 50. So I go out to 50. Which is a bit easier. Now I go out, I use the same 30, go out to 60, but I'm not looking for 30 at 60. It is 36, matches up to 60. So I go up, I use the 30 line because it's easy to identify. And I go up 6 places, and that would be right there. So let me just get rid of this one. Get rid of that. All right. So let's remind us, I think this is out also. All right. So this is my plot. Let me make a quick check. My plot is now completed. So far we have worked for 2, 4, 6, 8 points out of the 10 points that we are working for. Okay. Now to get the next 2 points is that I am going to take my ruler. All right. I'm going to take my ruler, but to represent my ruler, all right, I am going to use a line. And it's important that I use this to show you. All right. What you want to do, you want to let it go through your origin, and you notice the origin is G. So what I am doing now, I'm trying to get all these lines to pass, this line to pass through all those lines. So I'm not touching yet. All right. I could be comfortable with that. Now, how would we on our graph paper get this? Now we use a dot and a circle around the dot to represent our points. We use a dot and a circle around the dot to represent all these points, right? And when you're setting up your line, as you see me a few seconds ago, trying to ensure that either the line passes through the center or touches the edge, like a T here touches the edge. Yes, we want to get all these points very close to the line. It's not, the line is not going through the center of the point, at least it's touching that circular point that we make around our dots. All right. And if we go over to our checklist, our line is now off. So 2, 4, 6, 8, 10. And your graph is basically completed. You have just drawn the graph. All right. And that's how we um, represent or take the information from a table to put it on a graph. So let's see that. First, we want to ensure that our graph has its title. I'm not sure if I lost the title. I'm not seeing the title here, but we know we have yet see it here. The title is there. All right. So our graph has a title, and then each axis is labeled. You put your unit, your quantity slash the unit in which that quantity is measured. So if A was length, it would be length slash meter. If T was time, it would be time slash second. Good. And then what we do now, we want to ensure that we identify the highest number in our graph. Let's see if I can get back the graph quick and fast. The table. Let's see if I can get back the table quick and fast. All right. The table, put it over here. All right. I got the table. I got the table. Right. And see the table right here. We want to ensure that we identify the highest number. From the instruction, this column represents the x values and this column represents the, I should say, the A value, the B values and the A values. So this column had the A values, this column had the B, this was B values, these are A values. I'm trying not to get it confused. All right. So it was this A versus B. Now, these are the X values, these are the Y axis values. So I took these values and I look and I said 36. I tried to look and locate 36, but I noticed if I said, all right, turn around off this 36 to 40, I am able to go up by 10. Every 2 centimeters, I would have gone up by 10. And then I look here and I say it's 60. Also 2 centimeters going out, I can um, go up by 10. That's the scale right there, because now when the examiner look and say 2 centimeters, the first thing that we're supposed to see is 10 on the x-axis. What this is saying to the examiner or on the marker, that 2 centimeter is, when you move 2 centimeter, when you look every other line, you should see me going up by 10 on the x-axis. When you look on the y-axis, every 2 centimeter I should be also be going up by 10. All right. So that's all. And then what I did know, I know that 2 centimeters is 10 spaces. So these units must be divided by 10. And I noticed that when I, it was a one-to-one for me, because when I divide 10 by the 10 spaces, I get 1. And what I do on the x-axis, I just divide all the values by 1. On the y-axis, I divide all the values by that 1 that I get also, because when I divide the 10 on the y-axis by 10 spaces, I get 1. Even if it was as I again, even if my first every 2 centimeter was 5 units, that 10 spaces would have to divide into 5. The 5 would, and then you will get 0.5. Good. And all these numbers would be have been divided by 5 if it was on the y-axis. If it was on the x-axis, all these numbers would be divided by 0.5. And that's basically it for doing up your graph. It is as simple as that can be. Okay. If there's any, you can leave any comment, and if you want further information, feel I'll be happy, more than happy to help you all out. All right, thank you very much.